Well, hi, good morning. Thank you so much for joining me in my shop here. It's January 28th. It's been a couple days since I've been in my shop. Very, very busy at the end of this month. And so the last video ended with me poking around or wondering about a intermittent problem that becomes apparent when you adjust the trimmer screw here. When you reach a certain point and the radio's output drops. And then you go a little further and it kind of comes up again. And this is happening right where you're peaking this coil, it drops down. So I think right in the area where this transformer would be peaking properly, it's where this thing occurs. And what thing is it? Well, I don't know. Obviously it has something to do with the trimmer capacitor itself, but on the long shot that it may be something to do with the wires down at the bottom. I poked around down here and I did find what seemed like an intermittent problem down here, which I resoldered and seemed to make the problem go away down here. I stick poked it and went away, but here it's still there. So two different problems? I'm not sure. So how to approach this? So one way would be to take this can off and look at the stuff inside. This is the kind of thing that's inside there, something like this. And then what? Hope and pray you can spot a connection that just needs to be resoldered, because anything else, a little far-fetched that you're going to try to fix these actual coils. So the problem could be the actual capacitor itself. In fact, that's what I really think it is. I think it's the capacitor itself, and I think it's developing a short right in the mechanics of the capacitor. So how to approach this? Well, yeah, take the can off, but that's complicated. This can has a wire coming out the side of it down here, heading to the volume control. It goes through a hole in the side of the can. So if I loosen the can and try to pull it off, I've got this wire going through a hole. What's going to happen there? That's really quite a problem for taking the can off. So problem to get the can off. Once the can's off, what am I doing anyway? Chances are in the process the situation will get worse, because things tend to get worse, they don't tend to get better in situations like this. So what I decided to do is, before doing any kind of operation on the radio, which I'm kind of doubtful there is even a path forward for this, I want to examine the situation here by passing a sweep signal through the IF, getting the response curve on my oscilloscope over here, activating the problem, and then watching what happens to the sweep. And maybe that'll lead somewhere, maybe not. I'm going to give that a go, though. Okay, just about ready to go here. I got to decide where to connect my oscilloscope, and I think the best place will be just ahead of the 2.2 megohm resistor. We should put the connection right here. Okay. So let's take a look at the scope. I have a camera on it here so we can get a little closer look at it. So what's happening right now? Normally the scope has an internal sweep system, like that. But what I'm using is the sweep from the signal generator. It has a sweep output which is coordinated with its other radio output. So it's sweeping, of course, from here to here. This point represents 430 kilohertz, and this point 490 kilohertz, and in the middle is 460, which is the IF frequency. So what I'm expecting is a curve like this. Well, it might go down, probably a downwards curve in fact, and we'll see what happens. Now this little dot you see just above my finger, that's actually coming from a light on the camera here. That's not part of the scope. See? Okay, in case you're wondering, what's that dot on your scope? Okay, we'll go back to the longer view. This is the sweep generator. It's producing the sweep signal. The sweep is running at 10 milliseconds per sweep, whatever frequency that works out to. What we'll hear on the radio if I turn the volume up is we'll just hear a buzzing sound. As the sweep passes through the IF, it will generate an output and go to the speaker. And thump, 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 turns into bzzz, buzzing sound. There we go. Okay, well, try to make sure that I know which of these controls is the volume control and not the tone control. Okay, volume is up just a wee bit. Here we go. Let's start. Let's stop. I haven't plugged the radio in yet. Okay, let's try again. Here we go. Okay, the radio's warming up. I should also rotate this because what I'm hoping to do is tune the trimmer in that we're concerned about and watch the result on the scope. Now, you can't even see it. Let me turn this brightness up just a bit. This is tricky to make it show on a camera properly. Always looks a little different with my eyes. So we'll take a close look with this camera when the time comes. Okay, radio, we're not hearing a thing. Here we go again. Should be hearing this. Maybe I don't have enough output coming from the signal generator here. Wow, it's just totally stone silent. Okay, we'll turn it down. We'll pump up the output. Oh, there we go. Okay, so there's the buzz. You can hear, and you can see on the scope somewhat unexpected shape. So ideally, this would be straight on the top, sort of, and then just dipping down, or just dipping up one way or the other. Going in both directions? It's not quite what I was expecting. Now, you can't see it in your camera, but with my eyes, I can see there's another signal coming through here. It's, you can sort of see it. Yeah, you can, just above the tip of my fingernail there, you can see looks like a sine wave. Comes all the way along. It's tapering. You know, you're having trouble seeing it. I can still see it with my eyes, though. It's tapering down, and disappearing. What this is, I have no idea. What would that be? Huh. Let's tune the radio a little bit and just see what happens in case there's something going on with the. Oh my. Okay, so I tuned it to the. It's at the low frequency end of the dial. We're going to tune it the other way. Oh, this is not what you want to see. What was that? Some noise or something. Right here, yeah. I wonder if that's a. Well, we can turn the volume up. Wait a minute. Where did the something's not working out here? Something is not working out here. Okay, tuning back down. Yeah, this is not working the way it's supposed to. Well, what have I done here? So, tuning the radio shouldn't really affect this display. Just reviewing the frequency settings for the sweep. Starting at 430, stopping at just below 490. I should put this in the middle. It's close to being in the middle. Oh my, weird shape. Let's go on the other side of the 22 million ohm 2.2. This might quiet the radio. No. There's nothing there at all. This is a straight line. How do you get that? Well, that's unexpected. See the resistor I'm connected to, 2.2 right there, 2.2 megohms. One side we get, you can't see it now, just double checking. We get that double response curve display, and on the other side we get absolutely nothing. How can this be? How can this be? Let me switch cameras, in fact. So, I'm not sure at all what I'm doing here. Now, something kind of weird. Okay, let me turn the brightness back down. There we go. So this is on the grid side of the 2.2 megohm resistor. Now, I'm going to, if I drop the sweep input, if there's any AVC voltage, that will drop also. Let me put this on DC over here. It's shot right off the screen. There is a DC voltage here. There it is. Okay, check the 0 point. Let me just zero this a little better. The scope is 0 parallax with the grid work. The grid is on the inside of the glass of the scope. So there's no parallax with this scope. Okay, back onto DC. So we drop it's 0.2, so it's 0.4 volts. Peak, well, this is 0.4 volts. Okay, now I'm going to vary the output of the signal generator, and we'll see what. So the output now is 0. You can see the line is just sitting here. And if I crank it up a fair bit, let me really give it a whack here. Let me turn the volume down. Now 0.5 volt per division. I really gotta put in quite a signal to get it to come down here. This would only be, 0.5 volt, so 1.5 volts more. Don't know how that compares to a radio signal. What if I just put it on the antenna right now? What would happen? Difficulties, what happened? Okay. I like doing this kind of stuff. Just kind of hooking stuff up and seeing what happens, because almost always I'm left scratching my head. I don't. That's on the antenna, but the antenna is not switched on down here. So I have to stop for a bit, switch on the antenna, and then we'll keep going. See what happens. Okay, the antenna actually was on, so let's tune around, get a station. Okay, I'll watch the scope here. So this is the grid side of the 2.2 megohm resistor in the AVC circuit. So I'm going to tune in and out. We'll watch if there's any DC variation on this. So that kind of matches what I've measured with the indicating meter earlier. A fairly steady AVC. This is showing about 0.5 volt negative. Let me just check the ground again. Yeah, about 0.5 volt negative. I think I measured slightly higher when I was measuring it, and it varies just a little wee bit. Now I'm going to go on the other side of the resistor here. Okay, and see what's happening here. Okay, there we are. So let me just brighten this up just a wee bit. Okay, I'm going to move the 0 point up higher on the scale here. Higher on it. So that's the 0 now. First, you see a lot of RF in there. Yeah, I wish I could get on the camera what I can see with my eyes, because there's a lot more detail in there. Let me just see if I can just... That's a little better there. Where was I in 1957? No, I have no recollection of that. Just trying to get this set. There, that's pretty good. Okay, I'm going to tune in and out on the station now. So you can see here there's no carrier coming from a station to generate the what you see here. As far as, you know, which we'll dive into a little bit later this hour. And this RF in here is going to be at the IF frequency, 460 kilohertz. Some of the coordinators' jobs are now being filled. And it looks like the Eagles are bringing in... okay, you know what? I have not tried doing anything with that trimmer yet. There's a good oh yeah, we have to go back to the sweep generator, right? Okay, we're going to go off the antenna here, and we're going to go on the sweep generator, which is hopefully probably needs a readjustment. But well, that looks a lot better. What's the difference here? So we're getting a much better downward response, a much more muted upward response. Ideally, this would be flat across there. I hate to say it, but this looks like a female body part. Well, now, if I tune the radio, it shouldn't do anything. Oh my gosh, it's still doing stuff. Oh! Who's that? Okay, so I'm tuning the tuning dial. What? That's probably the radio tuning in a harmonic, a second sweep set, if you like, harmonic of the first. So the first is around 460, so this would be around 920. But I can't tell where the... Well, you know what? There are some marks on the back of the radio here. Well, I'm very close to 1,000 kilocycles. Yeah, that all makes sense. So what we're seeing there is simply the radio tuning in the harmonic of the sweep, like a second sweep at a higher frequency, harmonic frequency. Okay, so as we tune, and we'll bring it right into the IF frequency. So now the radio is properly converting the harmonic of the sweep to match 460 kilohertz. I think that's what's going on there. And we just continue on by, and we might get another one. What would another one be? The third harmonic? I'm tuning the radio further and further up band. Here's something. What's that little guy? That's probably it. There he is. And off he goes. The significance of that, there isn't any real significance. So, okay, so, but looking at the main But I'm tuning back down is what I'm doing. It gets bigger and bigger and bigger. So we're putting this in through the antenna. And I think what's happening is the front end tuning of the radio, as I tune the radio down, gets closer and closer to the IF frequency. Bottom of the AM band is 530, and the IF's running at 460, just below. So as you tune towards the bottom of the band, the radio will kind of receive a signal at 460 on the antenna better. Anybody follow that? I don't know. So that's why it's getting bigger as I tune down. I think that's the only reason. Or the way to really put it is, as I tune up, the front end tuning of the radio is suppressing the IF frequency I'm pumping into the antenna. It's not getting through the radio to the IF string as easily. Okay, so I got everything figured out. Maybe now it's time to fool with the... well, another thing to say here is that this is a beautifully shaped curve. If this is the actual response curve, which I believe it is, it's perfect. It just looks lovely. And is it rated 460? Well, that's a little bit trickier to find out. Even though I have the sweep set, carefully at the start and finish, the middle should be something. It is just a little. Well, let's check it right now. We'll check it right now. So we're starting at 427, but we really want it to be 430. So let me just adjust the signal generator slightly. Just bear with me here. Actually, here you can watch the excitement of this. Okay, so that's 430 quite accurately now. The stop frequency we want at 490. It's just a little low. Turn this up just a bit. That's about as close as I could ever get. Good. Away she goes. Now we'll take a look again. Okay, so you can see the start of the sweep right there and the end is right there. They're both on, and you can see it's slightly over. So this is suggesting the peak is just off 460. It's just a touch high. Now I am going to fiddle with that trimmer. Okay, so we're going to try to get the effect to come and go. And you should be able to notice it from the sound of the sweep. I'm just going in the screw. Here we go. Okay, so now I'm going to start adjusting the IF here. Oh my gosh. Oh! That's quite a difference between that and that. My hand is hardly moving. Couldn't be moving the screw more than a couple degrees. Well, maybe 5 degrees. It's shaky. Keep tightening it. Interesting. Never comes back. I'm loosening the screw. There it is. Now if I tighten it, I can get back to... Whoop, can't get to as sweet a spot I was at. A sweet sweep spot. Ooh, wow. Right there. Now it's very important to kind of overcome this, because we want this. We don't want that. While we got this on, I'm going to adjust the other IF transformer trimmers a little bit. Okay, I don't expect too much of a... Oh, look at that one. Well, we're going to stick it right on the line there. Okay, back to the first one. This is the first IF I'm adjusting here. Trying to get a combination of right on the line and also maxed out at the same time. Okay, this is... Oh! Okay, so I just stuck the... I'll show you what I did. Remember, this is all about trying to discover what is going on inside this can without taking the can off. That's what we're trying to do here. This is the one I was turning, and we were watching the signal go up and down, up and down. This one I just put the screwdriver in, and kabingo, it went off. So that says something, I think. Here we go. Let's tune this. I'll flip it back to the other camera here. Okay, watching. Okay. Now I think the radio is suppressed. Now I'm going into the sensitive trimmer, or the one that I thought was the sole sensitive trimmer. I can't get the screwdriver to set in. Okay. Whoop, 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 whoop. Didn't mean to do that. Well, obviously I triggered it. I wasn't watching or anything. Okay. Look at that. See it? Look at how big we can get it. And then, oh, that's fantastic. Any minute now it's going to quit. Yeah, just like that. Going back. It's kind of a hysteresis thing here. Back. Okay, so I'm now just wiggling the tool, trying to cause a problem. There's nothing happening. Okay. Looks like you have to be turning that screw to get the effect. Yet, now it could have been this is the problem, and it was on a hair trigger, and then I stuck the screwdriver in here, and I just managed to trigger this one by just touching this one over here. There's really nothing going on with this, and so I'm trying to decide, is the situation here due to the trimmer capacitor itself, or something down below it? Most importantly, a loose wire. The other thing about this too is the very distinct two operations with no scratchiness in between. That's very odd. So in other words, if you had some kind of a brushing contact in here, like a short circuit developing or something going wrong in here, and so as you bring it into contact, you expect a moment where it's and you can kind of fool around, as I've been doing, and try to get to that loose contact, and then you'd see it on a display or hear it come out of the speaker. But what we get is it's either here or it's there, or it's here or it's there. And those are my observations. Okay, so I'm going to go drink coffee and ponder what I've seen here so far. Try to figure out, what can you do about this? And I may have the answer already, actually. It's not the best answer. Oh my gosh, what have I got going now? So on the left is my SDR radio. My SDR radio is connected to the same point. The antenna input is connected to the same point as the scope. And I've got a capacitor. That's what this box is. The box is setting a very, very small capacitor to prevent overloading of my SDR. Doing this puts the SDR at risk, by the way. If you're going to do this, try this stuff, be prepared to blow up your SDR and say goodbye to it. So I'm trying to be careful here and not damage it. So far, successful. So, interesting. Let's just look at the SDR display for a minute. So, see up here it says 460, and if you look, there's a red line right here, and that red line is marking where 460 kilohertz is, and that's where you'd want this peak to occur. This peak is based on the sweep passing through the IF. So the strongest output of the IF comes when the sweep reaches right near 460, 459 and 459.9 or something. So that means the IF appears to be tuned correctly. The shape of this curve looks nice, although on a SDR it's a little questionable about that. What's going on here? probably the SDR itself is having some trouble processing this into a nice smooth image. We might be able to fix that a bit. Yeah, that looks a little better, doesn't it? Still moving around a bit. I'm just going to put this up just a wee bit. There. Okay. Why did I do this? So the reason is I'm taking a long shot here. That when you turn that screw and it does the thing, what's really happening is the tuning point of that transformer goes way off because the capacitor is being shorted or going open or whatever it is that's happening to the capacitor. You still have a resonant circuit in there with whatever's left of that capacitor on the coil. So the signal drops way off, but it could be that because one, the one we're fooling with, one of the 4 IF transformers is now tuned way off. And I hope to see that using the SDR. Right now the SDR is zoomed in on the IF. Let me just tune the radio a little bit. And you can see it's having really no effect. Very good. That's what you want. It's very interesting to oh, that thing's going through there, and you're not seeing it on the SDR. I have to think about that one, but I'm not going to bother. Let's cause the problem now. Cause the problem. Let's cause the problem. Okay, I wasn't watching. So we see a big drop both on the scope and on the SDR. The SDR, yeah, I told you what I did with the SDR antenna. The same spot as the scope. Come on, go in. Okay, there we are. We're in. So in the quiet mode, what we need to do here is I need to de-zoom this. This is zoomed way in on the IF, so let's unzoom it. Okay, so here you can see the IF signal over here. Now, we want to keep an eye open for something popping up along here when I'm doing this. In fact, we're in the quiet mode right now. And look at the size of that image there. Okay, here we go. Getting exactly the opposite to what I was hoping to see. Here she is working. So I'm looking at the waterfall display and looking for new signals appearing. Let me get this to go again. New signals appearing when the sound has gone low. The suggestion being that there's an alternate tuning point for this one transformer, and we'll be able to see it. We may not be able to see it because the sweep is not broad enough. The sweep is not broad enough, Jim. The sweep's not broad enough. Okay, we're going to broaden out the sweep. We're going to make the sweep go much broader. Think for a minute. Does that make sense? Yeah, if the transformer's tuning way out, then it could tune beyond the range of the sweep I've got, which is focused. Where are you? Focused around the IF. So I need to expand out the sweep. So let's do that. We will do that. Okay, so we will just because I don't know what else to do, we'll just do something here. We'll go way down. Okay, so we're like 100 kilohertz starting point. That's way down. And now we'll go up. The stop point will set way up, way up. point would be at 1,000,000. So if there is another resonant point somewhere between 100,000 and 1,000,000, we'll see it on the scope. Okay, I can get her going. So, we got a thing here, a thing here, and a thing here. But the SDR looks pretty normal. Now, there are signals kind of showing up on the SDR. I don't know where they're coming from. I see one up around 1800, and it just disappeared. Who knows what that is? It could be a ham. Could be a ham guy. Okay, we're gonna cause the problem here. Okay, here. Oh, yeah, lots more action down here now. Let us cause the problem. Overload. So when it's quiet, I'm looking on the SDR. I don't see another signal popping up. It would probably be a multiple. Well, not necessarily. I got no reason to think it's a multiple. I'm really fishing here. Interesting, you can see the resonance of the IF here and here. These are harmonics, I should say, of the IF frequency. Of course, the radio wouldn't do anything with these signals. It can only process the 460. Well, this isn't really going anywhere. Now, what happened to the scope? How come it went like it went? Why would it go? Oh, well, because the range now is totally different, and there's no way 460 is in the middle anymore. I guess it's out here, or maybe that's even the tuning of the radio. Yeah, that's me tuning the radio now. So that's the tuning of the radio. We can't. This is the IF right here. This little tiny pip is the IF. And what is this thing? So as I tune back and forth on the SDR, you can see something going back and forth. It's right around 1,000, right around 1,000,000 hertz. That's got to be the local oscillator going back and forth there. Wow, isn't this all really exciting stuff? But it hasn't helped me one iota. I don't know what to do here. I mean, what you know, the best thing I can do at the moment is tune this to the highest maximum result that isn't too close to the edge here. And where's that? Now wait a minute. Wait a minute. If this is a contact problem, why would there be a hysteresis in the effect? Almost mathematical one. And why is it right at the peak? Right at the peak. So I'm looking for inconsistencies as I turn the screw back and forth. I'm thinking to myself, if this is a contact thing going on, it's not going to be consistent, 100% consistent. It's gonna be, see, noisy. It's not always in the same spot. I think I just got past the peak there and it went. right there. Whoop. I'll bring it right close to the edge. And then, see, like, look, how can this be a mechanical problem? Okay, that's a good question to go drink some coffee on. Okay, I have to attend to other matters, which is a coded way of saying I have to go to the grocery store and do those life type things. So I sort of tried to uncover or discover more about this effect, and I'm still left unsure. Is it the capacitor? Is it a broken or a loose connection inside the can? Is it, or is it some? And I don't know why this would be. When you raise up the resonance just to the peak, something happens. I don't know what that something would be. So I don't know. I don't know. And that's basically where it is. I don't know what to do here, other than tune it as high as I dare. Don't get too close to the wonky spot, and call it a day. That's probably where this is going, because I really don't know how else. Even if I had some notion as to what the problem was in there, it's not necessarily something you can fix. Like get out a screwdriver and fix it. It's not necessarily like that. Okay, thanks a lot for watching, and I won't be in here again tomorrow. Be busy, so it might be a couple of days before I get back at this again. That'll give me some time to think about what to do here, if anything. Thanks a lot for watching. Have a great day.